Welcome to the 190th monthly meeting of the New York Linux Users Group. Thanks for coming out. Tonight we're going to be hearing from Josh over here on the topic of HHVM, Facebook's PHP and hack runtime. This is Josh Watzman, who will be giving a brief introduction to the history and architecture of HHVM, as well as their implementation of PHP and its history and implications. I'd like to say how much we appreciate Bloomberg for allowing us to use this space, and thanks to everybody here who came out tonight. We appreciate your presence, and we really try hard to find things for you that will bring you out and that interest you. In addition to our space sponsor, Bloomberg, right? I'd like to thank our other sponsors who are in the past and present, who have been IBM, Canonical, Brandor Group, Google, and O'Reilly Media. They've all supported us and, for the most part, continue to support us. We really do appreciate that. In addition, NYLUG would not be able to function without our many volunteers who contribute greatly over the years and to help run the various projects that we have. Everyone, please welcome Josh Watzman on HHVM, which you could also think of as PHP++. Take it away.
Thanks. So yeah, my name's Josh Watzman. I'm a software engineer at Facebook, and I work on the HHVM project. HHVM stands for the Hip Hop Virtual Machine. It's the runtime that Facebook uses in order to execute all of our front-end PHP code, as well as all of our front-end hack code. Hack is Facebook's dialect of PHP. I'll be getting to that at the end of the talk. Before I get started, I want to give a special thanks to Paul Tarjan and Sarah Goleman, whose talks this slide deck is basically an amalgamation of. So thanks to the two of them. So for this talk, first I'm going to be talking about the PHP language. Then I'm going to talk about the HHVM runtime and how we actually execute that code. And then I'm going to circle back around and talk a little bit more about the language. So first of all, PHP at Facebook. Facebook has something like 100,000 PHP files with tens of millions of lines of code. We do 10 releases per week. We have a lot of PHP code, and we iterate on it very quickly. So the efficacy of the PHP language is really important to Facebook. Anecdotally, good engineers are really productive in PHP. People like to make fun of the PHP language. It certainly gets a lot of flack, and I'll be giving it a little bit of flack myself in this talk. But it turns out that there are a lot of things that are really nice about the language as well. And so I want to start with that so we don't lose sight of what's actually good about the language. The two things that stand out to me as being really nice about the PHP language are, first, a clean request model. So in PHP, whenever you start executing a web request, you have a clean slate. You have some code that begins executing, but it starts with a clean slate. All of your variables are uninitialized, no globals, anything like that. You can then run some code, do whatever you want, and then at the end of the request, everything is thrown away, and the next request starts blank anew. No global variables shared between requests, no state persisted or anything like that you don't explicitly persist to a database, write to a file, put into memcache or something like that. This is a really nice paradigm to work with. You don't have to worry about any sort of state pollution, mutexes, requests happening at the same time. None of that. The runtime deals with keeping everything separate for you. More importantly to me, the major feature that PHP has that I've really not seen in any other web language is such an incredibly fast edit, refresh, iteration cycle. When you write some code in PHP, you save it in your editor, you tab over to your browser and hit refresh, and you can see your changes take effect immediately. There's no lengthy compilation step, no lengthy type checking step, no lengthy anything. The changes just take effect immediately. And for the velocity that Facebook is moving at, this is incredibly important. I'll be coming back later talking about how we've modified the language and made our own dialect of it and how we've preserved these nice features of PHP. But I just wanted to start out talking about some of the nice things that PHP has and what has actually served Facebook really well. But I want to make fun of the language a little bit too, because that's always fun. So we're going to play, little quiz. What does this code do in PHP? Everyone's favorite game. What is the string 1 plus the string 2 in PHP? Any guesses? I hear 12. I hear 0. Any other guesses? 3, as a matter of fact. It is 3. PHP will notice that your strings look like integers, will convert them to integers for you, and string 1 plus string 2 is the integer 3. Not the string 3, the integer 3. Okay, so how far does this go? What about this? These two strings. What happens if I add these two together? Yeah, I still heard someone say 3, and that's exactly right. PHP considers these integer-like strings. Importantly, the plus operator here is not string concatenation. There's a different string concatenation operator. So this is an integer plus, and so it goes, well, I guess you meant, well, this kind of looks like 1, and this kind of looks like 2. We'll just cut it off after the integer part, and you get integer 3 back. Great. Okay, so this is a little annoying, but like, this almost makes sense. How far does it generalize? Does it understand hex in particular? What about 0xf? What happens here?
15.
Is it 15, 30? It's 15 as a matter of fact. PHP will go, this is, what was that?
It doesn't understand hex.
Doesn't understand hex, no. So, at least I guess it doesn't, right? 0xf, this looks like a string that has a 0 on the front. Integer 15 plus integer 0 is that conversion, and we get integer 15. Okay, so it doesn't understand hex. So what should the result of this be then? This should be false, right. So this is either string 15 is not the same as string 0xf, or integer 15 is not the same as integer 0. And so of course, since this is PHP, this returns true. It does the hex conversion here. It sometimes does hex, I guess. PHP, I don't know. So what about this one? This isn't a number at all. Guesses? 0, null, I think I heard someone say 2. It's in fact 2. This string, well, I guess it's sort of like 0, right? Can't convert this to an integer. 0 plus 2 is 2. So I guess non-numeric strings are 0. So then what should this be? This is a binary, or like a bitwise OR operator. What should this return? I would expect 9 million, right? We have the string on the left is going to convert to integer 0. String on the right is going to convert integer 9 million. So I'd expect 9 million. I have no idea. I do not know where this comes from. Okay, so believe it or not, this gets worse. So what's this? Right? So we said earlier that the string hagfish converts to the integer 0, and 0 plus plus is 1, right? You're incrementing the string. The h increments to I. Okay, so we can increment strings like this. So then the question that then at least comes up in my mind is what happens if you increment z? It's AA. It's AA. Someone said AA. Because everyone loves Excel. Okay, so yeah, there's a lot of weird crap in the language, and I'll be coming back to that a little bit. Some of this crap is what makes it hard to run PHP fast, but it's not the only thing that makes it hard to run PHP fast. A lot of it comes down to PHP is a highly dynamic language, and so a lot of the things that make PHP hard to run fast, it turns out, would make languages like Python or Perl or Ruby or anything like that, which most people consider reasonable languages as well, also hard to run fast. So how do we run PHP fast? A little bit of the history of the project first. So people might have heard of the hip-hop compiler, or we call it HPHPC. This was our first attempt at running PHP fast. It transpiled your PHP code into C++, then used GCC to build this gigantic ELF image that we would then deploy this giant ELF binary across the fleet. It was like several gigabytes large of all of our PHP code. So this, as a first attempt, this worked really well. A 2 to 5 times win over interpreted PHP. It's important that a lot of the win from running dynamic languages comes from type inference. From knowing this thing isn't some arbitrary object, I don't need all of this complicated logic to figure out what it is, what conversions need to happen, anything like that. I just know this is an int. It fits in a register. I can use the inc x86 instruction on it in order to increment this register instead of doing some complicated +1 or anything like that. And GCC can figure that out for you if you tell it that it's an int as opposed to some complicated object. This was open source at the time. The project has moved on and is now the HHVM project. But if you dig through our GitHub history, you will find back in 2010, 2011, the remnants of this source code, if anybody's particularly interested. I wouldn't recommend it, but it is there. It was open source at the time. So why did we move away from PHP to C++ transpiling? Our current solution is really a JIT that goes from PHP into x64 assembly directly, a real JIT. So why was the transpiler not really the right thing? The big thing in my mind was that there were separate development and production environments. When HPHP-C, the PHP to C++ transpiler, when that was in production at Facebook, I wasn't working on the HHVM team. I was a product engineer working on Newsfeed. And so I was one of the major users of this, the product engineers at Facebook. And so the separate development and production environments were just killer. It takes about 45 minutes to take Facebook's front-end code, transpile that to C++, compile it all with G++, link it into a big image, and then have that and start that up. And this is with like a fleet of like 200 compilation machines. We had like put giant resources behind it. Still took about 45 minutes, something like that. This would have killed the fast edit refresh cycle of PHP that I was talking about earlier. 45 minutes between making a change in your code and actually being able to run and test your code is absurd. That's not going to fly when you're used to like 100 milliseconds. Too many orders of magnitude there. So that means that we can't use the transpilation, the transpiling process whenever you're developing code in your developer sandbox in a development environment. That means that HPHP-C had to have its own interpreter that was separate from the PHP 5 interpreter. The runtime code was shared, but a lot of the actual execution engine was not, meaning that we had a separate environment for production and for development, which leads to a really exciting class of bugs. Bugs where things work when you are testing them, and when you deploy them, they don't. My favorite one, right, these were always like edge cases that you would never have thought of. My favorite one, this is an actual bug that I actually hit one of these bugs that like stopped a deploy because it broke in production and not in testing. If you defined an interface, and the interface had a constant in it, and the interface also had a method in it that had a default value that used that constant, then you had a class that implemented that interface and implemented that method, and you did reflection on the class and tried to get the default value of that method, and the method referred to the constant via the class and not the interface that defined it, then it would say that it didn't exist. Only in production. I actually hit this, believe it or not, and like it actually blocked the release of one of the revamps of our iPhone app several years ago. It was a big deal that we hit this. So yeah, bifurcation between development and production environments, never what you want. Bugs that happen in production, never what you want. So that was one of the bad things here. But beyond development process, there were really other good reasons to not use this compilation process, this static compilation process, which is, I said a minute ago, type inference is a big deal for performance, and ahead of time type inference is difficult at best. There are certain classes of things that you can do. But it turns out, if you actually know what the actual values of things actually are at runtime, right now, right before you execute a function, you can specialize the code in that function a whole lot better than if you just are doing some sort of complicated static analysis. No matter how complicated, how advanced your static analysis is, on a dynamic language without a type system, you can't know for sure all the time what all the types are. So you can guess sometimes, you can do pretty well, but it's nothing compared to actually knowing at runtime. And what I've just described is sort of the canonical example of why you have a JIT, which is why we have now the HHVM project, the hip-hop virtual machine, which is a JIT that executes your PHP code. One other problem doing ahead-of-time compilation is the difficulty with dealing with the extreme dynamic nature of PHP. And I believe, yeah, I have an example of that. So this is the sort of thing that you can do in PHP. So this is a pretty absurd example. It's for illustration on a slide. It is occasionally useful to do stuff like this, though. So what this does is it picks a random number. If the number is even, then it defines the function parity this way. If the number is odd, then it defines the function parity this way, and then it calls that function. It's worth noting the function parity does not pick a random number and then return one thing or the other. This is actually conditionally defining different functions depending on what random number you happen to pull out of a hat whenever you first load the file containing this code. So the way HPHP-C worked when it translated to C++ is it would take your code and build like C++ functions and classes out of them. The semantics of C++ and PHP sort of at a high level, you have functions, you have classes, we should be able to translate that, right? This has no matching semantics in C++. You can't conditionally define functions. Your functions are like, targets of a jump instruction in your elf image. You can't conditionally define them without a bunch of like complicated runtime shenanigans. With C++11, you sort of have lambdas. We didn't have C++11 at the time, but really you can't do stuff like this without very complicated bookkeeping. It turns out we just disallowed stuff like this altogether, which mostly works, but you're reducing some of the power of PHP. Again, this is kind of an absurd example on the slide. It's for illustration, but there are occasional cases in which you actually do want to do stuff like this, and it's useful, and the language should support it, and HPHPC didn't. I'm just going to blow through a couple of other examples of why it made PHP hard to run fast. One of my favorites is here on the right, the array structure in PHP. It's sort of an ordered hash table. You can, have an array literal up here. This array bracket is the append operator. So you can append, but you can like remove things in the middle, and it's not contiguous anymore, right? I still have the keys 0 and the key 2. I can take a map-like array and append to it, and now I have some weird hybrid. The semantics of stuff like this, well, developer confusion aside, it's perfectly possible to build like an array object in C++ that has these semantics, that has like an unset member function on it, that has a append member function on it, that maintains these semantics. But now you have this complicated structure. It would be really nice if we could know, okay, most of your arrays actually look like this. They're contiguous vectors. We should just lay them out contiguously in memory. You can't really know that ahead of time. And it turns out you can do crap like this. With a JIT, you can see the array actually is contiguous in memory. I can just allocate that and can fall back on the other stuff. Again, perfectly possible to do in C++, a lot easier to do when you actually have the runtime values to specialize everything with a JIT. Reference counting is another favorite one of mine. I won't go into it. It turns out objects in PHP are reference counted. You can have references in PHP. Little known fact, you can determine in user space PHP code whether the reference count of something is 1 or greater than 1. The fact that it's reference counted actually matters for the semantics in one place. Makes it hard to do compilation. I won't go into it. Another weird side case in PHP that I think is fun. Okay, so now I'm going to go a little more into the technical details of how HHVM actually goes from PHP code to x64 assembly, by way of talking about compiling this line of code. This is going to get into some gritty details of what the different intermediate languages look like. There's going to be some assembly on the slides. If you're not into that or don't understand it, don't worry too much about it. There should still be enough for like the high-level process of what goes on here. So again, high level, executing this line of code, we're going to go from PHP source through the pipeline and have assembly out the other end that we can actually execute on the processor. So this line of code, $n equals 4 times n plus 1. This does what you'd expect. We're going to have a local called $n, multiply it by 4, add 1, and write it back into the local $n. There's no PHP trickery up my sleeve here. This is the pretty straightforward operations that you'd expect. We're furthermore going to assume that $n is defined, that it's holding an integer, just for the simplicity of going through this example. So for people that are compilers people in the audience, you probably don't want to go straight from source code to spitting out assembly on the other end. It's really nice to go through one or more intermediate languages in the middle. You can sort of de-sugar things, massage things as you go along before you get to the assembly, to the final output. And HHVM is no exception to this. We actually have 2 intermediate languages. The first intermediate language is HHBC, the HHVM bytecode. This is a low-ish level bytecode. It's not typed. It's also importantly a stack-based language, like Forth, for people that are familiar with that. And it's the first language that HHVM uses whenever it's going through the code. So let's look at what the HHBC is for this line of code here. This is what it looks like. There are 6 instructions. So it's a stack-based language. So let's go through what's going on here. Instruction 0 is int 4. This instruction pushes the integer 4 onto the stack, which we're going to need because we're multiplying by 4. Instruction 1 is cgetl0. This stands for cell get local 0. The cell part isn't particularly important, but get local 0. The name $n has been erased, but well, $n is the first local, so it's going to be local 0. And so the cget L0 is going to reach into whatever data store locals are in and push the value of that onto the stack. Then we have the mul instruction for, you can probably figure out, stands for multiply. This is going to pop off the two top items on the stack, which are going to be this int4 and the local $n, multiply them together, push the result back on the stack. So now on the top of the stack, we have 4 times n. We've multiplied them together. We're going to go execute the int1 instruction, going to push the integer 1, and then as you expect, the add instruction will add 4n plus 1, push that back onto the stack. And then finally here, line 5, we have set L0. You can probably figure out that stands for set local 0. It pops the top element off the stack, which is 4n plus 1, writes that back into $n, and now we've finished compiling this line of code. So things to note about HHBC. Again, it's stack-based, which is mostly just for the ease of thinking about this language, for the ease of like compiling down to it, for the ease of writing an interpreter for it. We actually have an interpreter for HHBC that interprets it directly without going through the rest of the pipeline. This was useful during the development of HHVM. It's not used a whole lot nowadays, maybe on Mac OS X where we don't have the JIT support yet. But for the most part, HHBC is used for one of its other properties. It's a little lower level than the PHP, meaning that we don't have to worry about parsing or building an AST or anything like that. We've already sort of chewed on the code a little bit. But it's not typed. It's not specialized to any of the types of the locals or anything flowing in and out of the function. That means that we can save the HHBC and only regenerate it if your source code changes. We don't need to keep regenerating HHBC when the types of your variables change. Again, one of the big wins of the JIT is specializing code based on the types of your locals, so we will end up regenerating the rest of the pipeline. In particular, we need to regenerate the assembly. But we want to start from something that we don't have to regenerate every time, that's really easy to write a machine around, to have the rest of the pipeline work from, so it can regenerate its specialized. Okay, HHBC, not typed, but we eventually want things to be typed based on the types of locals, so we can generate typed assembly, nice low-level assembly instructions. So the next intermediate language starts to do that. This is HHIR, the HHVM intermediate representation. Really clever name. This is going to be a typed language. It's also going to have everything in SSA form. Again, for non-compilers people, that stands for static single assignment, SSA. It means that you're going to have a bunch of temporary local variables. Each of them will be assigned to exactly once and then never reassigned. This form is really nice for building assembly, it turns out. It's really nice for compilers to work with. I won't get into the full details of why that is, how you generate it, but you'll be able to see in this code that it as a matter of fact, behaves that way. So here's the corresponding HHIR that'll be generated from this HHBC over here, again, assuming these are all integers and assuming $n is an integer. The first instruction we execute is perhaps a little bit of a strange one, instruction 0 here. Guard loc int 0. This instruction says, I have generated the rest of this HHIR assuming that local 0, $n, is an integer. If $n is in fact not an integer, then you need to go back into the JIT and regenerate this code, assuming $n is, well, whatever type that it is right now. You need to go like redo this work. That means we can just like jump straight to this code, and it'll figure out itself if the code is actually applicable. If you don't understand that, I'll be going through the process of how that works in some more detail here in a couple of minutes. So now we're able to assume that $n is in fact an integer. Then we can actually go and load local 0, load local. Again, local 0 is $n. We're loading it assuming it's an integer, and it's going to go into temporary variable 1, which is, again, a typed variable, an integer. HHIR is all typed. We're in SSA form, so we're going to define temporary 2. We're not going to redefine temporary 1. T2 equals T1 times 4 with the multiply instruction. Add 1 to that temporary, you get to this temporary 3, and then store local 0, temporary 3, which is an integer. Again, sort of lots going on behind the scenes here to actually translate these forms, but this is what the HHIR looks like out the other end. Okay, so now we have PHP, untyped HHBC, then we use the types of what things are going on to generate the HHIR, Now finally we can go from HHIR into x64 assembly. And so here's what the corresponding x64 assembly looks like. Again, this is probably exactly what you would expect. The guard local instruction is just loading 8 bytes off of RBP, dereferencing a pointer basically in C terms for people that aren't familiar with assembly, comparing it against the hex value A, which turns out to be the type of integer. So this is loading the type field of local 0, which the JIT just sort of knows where it is, pulls the pointer, compares it against the value. If it's not type of integer, we're going to jump into this thing called retranslate stub. That's what I was talking about earlier. This is the, oh no, the types aren't what I thought they were, we need to regenerate some more code. Again, I'll go through the process of how that works in a moment. If it is an integer, well, we can just load the local. This is in AT&T syntax. Load the local from hex 10 off of the base pointer into RCX. We can then load the constant 4, multiply RCX by the constant 4. We only need these 2 instructions here because it turns out you can't multiply by an immediate in x64. We're going to add 1, just the increment instruction, and then store back this location here is the location of the local, the same one we loaded here. Fairly straightforward compilation here. Going from HHIR into assembly is not terribly complicated, and this is what it looks like. So that's just one line of code. How do we do this for bigger bodies of code? What does this look like? In particular, let's look at this function. This is going to be we're going to talk about the compilation of the function f. F is going to use this empty construct here in PHP, which just says, well, if not empty, a sub k means is a sub k defined and set to something non-null. The exact semantics aren't important. What's important is, like, does a sub k exist? If it does, print k, otherwise print miss. We're going to execute this function f twice with the same array a, but once with the integer 42 and once with the string hello. So we're going to execute the function f twice. The type of a here, the first parameter to f, is going to be an array both times. The type of k is going to be an integer the first time and a string the second time. So we're going to look through how it regenerates code and links things back together. HHVM compiles code in what's called tracelets. Tracelets are short blocks of code with no control flow inside of them. And then they end with one piece of control flow that will go to one of 2 different tracelets. So for example, this function here, if empty, the first tracelet is 73 through 90 up here that does the empty test. I'm not going to go through all the bytecode instructions, but that's what it is, doing the empty test. After we do the empty test, then the end of that tracelet is going to jump to one of 2 different tracelets, depending on if it was a hit or a miss. Then we have the hit tracelet here and the miss tracelet here. And then no matter which of those 2 tracelets you go into, you're going to jump into the common end tracelet, which is the implicit return null at the end of this function. So there are going to be 4 different tracelets here we're going to deal with compiling. So let's look what happens whenever we start executing the function f the first time. We're going to call f with A42. So the JIT's going to go, okay, you're calling f. I have never compiled the function f before. I have this bytecode sitting around. The bytecode's untyped. So we built all the bytecode when we loaded this file. But I have no HHIR, I have no assembly, I have no type information now until you actually call the function. So let's go actually generate some of that. So it's going to say, okay, here's the first tracelet, this empty call. Local 0 is going to be an array. That's the first parameter. Local 1 is going to be an int. And so I'm going to generate code assuming that. As a matter of fact, the place that it generates code is called the translation cache. This is where our JIT writes the x64 assembly. This is readable and executable, or excuse me, writable and executable memory. It's where all of our code goes that we jump into. So we're going to compile this tracelet, and we're going to go, okay. This tracelet's going to start off with 2 of those guards I was talking about earlier, saying, you know, local 0 had better be an array, local 1 had better be an int. I've compiled this code assuming that it is. Then I'm going to have this empty block, and then that's the end of the tracelet. The end of the tracelet can go one of 2 different ways. I've not compiled either of those 2 different ways, and so those are going to go back into the JIT if we hit either of them. I've also not compiled what happens if local 0 and local 1 aren't those types, and so those guards are going to fall back into the JIT if those fail. So okay, JITted this code, let's jump to it. We're going to execute this empty. It turns out The array A does not have the key 42 in it, so we're going to go into the miss case. We're going to jump into the miss tracelet, but oops, the miss tracelet hasn't actually been compiled yet, so we're going to land back into the JIT. The JIT's going to recompile the miss tracelet now, again, assuming local 1 is an integer. It's going to execute this code. If local 1's not an integer, we'll fall back into the translator. But again, it is because we're building the code so that it is, and we'll finish executing and JITting this tracelet. Okay, that's the end of the function. Then we're going to come back around and do this second call to F with the array A, but now the string hello. So same tracelet, but local 1's going to be a string now. The runtime's going to say, okay, I've compiled this tracelet before. I have the assembly sitting in the translation cache, so let's jump to it. Okay, let's go through the guards. Local 0 is an array. Local 1, oh no, that's not an integer. Local 1's a string now. Jump into the translator runtime. We're going to regenerate, rejit this code, specializing it, assuming local 1 is a string now. Then we're going to rewrite this pointer. We actually go back and change that jump instruction for people that remember the assembly. But it's going to rewrite this back into a new compilation of the same tracelet, saying that now local 0 is an array, local 1's a string now. We've generated this code assuming local 1's a string and specializing to that. We're going to do the same empty test. We're going to link the jump over the hit into the miss to the same tracelet here. We've already compiled that. But the fall-through case, the hit case, that hasn't been compiled yet. It turns out we're going to use the hit case, this fall-through, and we're going to compile that last tracelet, the hit tracelet, assuming local 1 is a string, and then we're done. This is all of the code that the JIT ends up generating for those two calls. There are a bunch of other combinations of types that are possible, but none of them actually appear, so we don't generate specialized code for them. We generate specialized code just for what happened. But the code is specialized. We've used the runtime type information. We know exactly what things are, so we can specialize all this code to the integers and the strings and emit just increment instructions and other string manipulation instructions to make really fast assembly code that runs this really, really fast. Okay, enough of assembly details. Let's talk a little bit about open source. HHVM is open source. I alluded to this earlier. The source code's all on github.com/Facebook/HHVM. But it turns out open source really means something and needs to mean something. Throwing the source code over the wall isn't enough. You need to maintain packages. You need to help people actually build and deploy the darn thing. You can't just throw the source code over the wall and assume good things will happen. So the HHVM project didn't always quite get this right. I'm going to go through sort of the history of the project as an open source project by way of a few graphs from GitHub of contributions to the project, starting from 2011, and I'll keep showing more and more of the graph up to present day. And this is commits into master. So in the 2010-2011 era, we very much were just, throw it over the wall. Pushes to GitHub were sort of, whenever someone gets to it, I guess, whatever. We completely ignored issues and pull requests on GitHub. Didn't really tend to the project very well. There was basically zero documentation. The build system was a joke. You needed to patch libcurl and libevent on your local system in order to get the thing to work. These patches were things that upstream was never going to take, no matter how hard we tried, which we didn't, but they wouldn't have taken them anyways. And so this was basically a joke. I think one person ever got it to work outside of Facebook, and that was my roommate. Well, he was also a Facebook employee, so it depends on how cheating you think that is. But he had a deployment of it outside of Facebook's internal infrastructure. But this was saying this was hard to use is the understatement of the century. Most importantly, and worst, look at this. 0. It went dark in late 2011 and continued dark through much of 2012. Pushes completely stopped. So in late 2012, this was very much the era of, oh right, we have an open source project, we should do something about that. As HHVM at this era, at the end of 2012, was beginning to be deployed at Facebook and beginning to replace HPHP. And then we open sourced it in the existing repository, replacing all of the code. And so it's like, okay, we should really tend to this project and actually make this something usable. This is actually a really nice piece of technology. Let's make it really usable outside of Facebook. So we built up a semi-daily push process. It was semi-automated, semi-not. Someone still had to push a button, but it was better than the whenever push that we had before. We began working through the backlog of issues and pull requests that had built up through this area here. My laser pointer still isn't working. We were still really thin on documentation. The build system was a little better. I think you only had to patch libevent and not libcurl at this point. Still pretty absurd, but one step better. We launched an IRC channel. We launched a Facebook page and some social channels. Things started to get together, but 2013, you can look at the graph and see that's really where things started to take off. Internal development was continuing to ramp up and ramp up and ramp up, and we also ramped up open source development. We formed a dedicated HHVM open source team to look after the project and make it usable externally. We automated the push process with multiple daily runs to make sure that the fresh code was getting out there fairly regularly. One of the most important things we did was declaring bug bankruptcy. We went through, we closed every open issue and pull request. They hadn't been tended in 3 years. There was a lot of crap in there. It was just getting in our way. Most of it wasn't useful anymore. Most people that reported it had given up years ago. So we nuked everything. It's like, okay, we're going to start fresh. We're actually going to triage things properly. We're going to really care about this now. And then that worked. In the intervening years since then, we've closed more than 2,000 bugs legitimately and merged more than 1,000 pull requests. So we actually really started to, get ourselves together and take care of this project well. 2014 was really the year of bringing down the walls. Getting into a point where our code review is mostly open. We're still working on that, but most of our diffs are reviewed in the open. Pull requests are reviewed in the open. We were integrating with Facebook's CI system. So when you send us a pull request, we will suck it in and run it on Facebook's extensive testing infrastructure. We will tell you if it breaks tests against Facebook's www. Those tests are not open source. Our www is not open source, but we can give you information about test failures that came from that because you're running on our CI system. We had proper documentation on docs.hhvm.com. Our build system is no longer a joke. We actually ship Debian packages and Ubuntu packages that you can just install. No patching of system libraries required. Actually building it on our modern Debian and Ubuntu is not particularly difficult. apt-get, a page-long list of dependencies, cmake make. A few other important things. We released the Hack programming language in this time. Again, all open source. Hack is Facebook's dialect of PHP that has been in development for a while. I'll be coming back to that later. We announced a PHP language specification. We automated our push process completely. 30 minutes maximum after a commit happens internally, it gets pushed out externally on a cron job, no human intervention. So everything's happening. We are a real open source project at this point. No giggles or anything in the back from that. This has had a real effect. Here's a montage of committers to the HHVM repository. A few of these people are Facebook employees, but a lot of them are not. There's Joseph there from Box.com. There's Simon there from New Zealand, company called Pocket Rent, and a bunch of other faces and random avatars with pass-by pull requests of really cool stuff. There's come in, drop something, and disappear again. Really awesome stuff. Contributions from all over the place. So this has really paid off for Facebook, and it's also paid off for the rest of the world too. Not only has Facebook been in 100% production since 2013, our work on making HHVM usable outside of Facebook has paid off for everyone in this room too. I'm assuming everyone here uses Wikipedia. Wikipedia recently deployed HHVM, dropped the edit time of the Barack Obama page from 20 seconds to 6.9 seconds. This was a huge deal for them, for the latency of their saves and for their capacity. Baidu, it turns out, a major Chinese search engine, is also deployed on HHVM. They've migrated nearly everything, and there are several other deployments in the works as well. Okay, so let's come back to everybody's favorite game. Guess what that PHP code does? Okay, array literal, 2 elements, first and second. I'm going to print out the 1th element of this array. What does this print? This print, as you'd expect, second, yeah. Nothing strange going on here. Okay, what if I do this to a string? What does this print? A, yes, exactly. A lot of languages treat strings as arrays of characters. Looks like PHP does too. This, I think this is a little weird, but a lot of like really principled languages, like even like Haskell, for example, treat strings this way. So this isn't particularly bad. Okay, so let's talk about the list assignment syntax of PHP. We have, again, a two-element array literal, first and second, and we use this list syntax here. For people that aren't familiar with PHP, this is sort of a primitive form of pattern matching. And so I'll just give the answer here, since this is really the definition of the list syntax. We're going to assign first to A, second to B, and dump out first and second. Okay, so now, here's the quiz. What happens if you use that on a string? What are A and B here? Some people are saying H and A. It turns out that's wrong. They're null and null. I guess strings aren't really arrays of characters in PHP. So then what does this print? I would certainly expect null and null. I've done nothing here but use an intermediate variable for this hagfish string. And of course, since this is PHP, these two are different. Again, I realize I'm very much harping on some corner cases of the language. You're never actually going to do this in particular in production code. And if you do, like, you have bigger problems than that. You shouldn't be using the list syntax on strings at all if you hit this. So I'm making fun of some of the corner cases, and I actually think I have one more case here to make fun of. This is more for PHP experts. What's the problem here? Anybody see it? I'm going to say write a message, grab a line off of standard in. If the message is falsy, if it's empty, say echo empty message. What's the bug? Any PHP people?
Buffering?
No, non-output buffering.
This always true?
Sorry, what was that?
What's in the parentheses is always true?
No, it turns out you're on the right track though. No, so if I enter an empty message, like the empty string, just hit enter, then this will say empty message in the back. Yes, exactly. String to integer conversion. If I enter the message 0, the string 0 will convert to the integer 0, and that's false in PHP, and it'll tell you it's an empty message. I personally really like the comment 0. I like writing that message and sending that to people. And if you disallow me from the message 0, I'm going to get mad at you. I'm also going to laugh at you because you probably have code that looks like this. So I've been making a lot of fun of PHP in some of the corner cases. And so the first thing I want to make clear is that I'm doing this because it's fun to make fun of PHP. I actually really like the language, and it comes back to what I said at the beginning. The fast edit refresh cycle, the clean request model. Those are things I haven't seen anywhere else, and they are amazingly nice to program with. And the rest of the language certainly has some really nasty corner cases. Things that are going to hit you a little bit every day, and in aggregate are going to add up, but are still worth it, because PHP is so nice to work with at its core. And that brings me to Hack. Hack is Facebook's dialect of PHP. It's our attempt to keep the really awesome core that makes PHP nice to work with, which is, most of the language actually, and sand off some of these sharp edges that make it painful in aggregate and that cost you time. So why do we do this? What's at stake here? Why do we have our own language over PHP? Why don't we just deal with this? So there's a few reasons we might do this. The first is the consequence of subtle bugs. We don't want to have subtle bugs in our code. My favorite one is database corruption, for example. You converted a null to a 0 or vice versa, and then wrote that into your database, and you had a bug that did this. Now you've got to go back and run a big migration job on your database. I hope those two weren't semantically meaningful and you can actually fix it and don't have to do something much more complicated, or you're just, out of luck. Having a dynamic language with some of these sharp edges can make difficult APIs. You might copy-paste code, change around some of the type information because it's difficult to work with, because you don't completely understand the semantics of some of these corner cases and are scared of what might happen. You have a hard ramping up time for new engineers that have to learn some of these corner cases. And it also makes it difficult to refactor your code when you inevitably realize that you've made a mistake. These are all different ways of saying that having a language without these corner cases helps you manage technical debt. And managing technical debt is important because you're going to be refactoring your code no matter what. Obligatory cat gif. This is what you don't want to happen when you go and refactor your code. So how do we fix this? What is Hack? Hack is a statically typed language for HHVM. It is PHP with a bunch of other features, including a static type system is the one we're talking about here. It has a bunch of other nifty features too that I just want to mention in passing. Async functions, collection APIs, and like 10 different other minor features. But a static type system is one of the major ones. It's also completely backwards and forwards compatible with PHP. Hack is just a dialect of PHP, meaning that it has the same runtime representation inside HHVM as PHP does. The HHBC and the HHIR, you can't tell if you started with hack code or PHP code. That means that there is no overhead in the runtime between calling back and forth. It's completely free. And because the languages are so similar, there is no overhead in your developers' heads either for switching back and forth. The languages look really similar. If you know PHP, you know Hack. You can adopt it incrementally with no cost. You can rewrite, or not rewrite, you can add types to corners of your code as it makes sense. You can keep corners of your code that really do need to be super dynamic and untyped. You can keep them in PHP. You can fall back on PHP if you really want to. Or you can use the static type system that helps get rid of some of these nasty corner cases. Importantly, even when you're using the fully typed versions of Hack, Hack keeps the good parts of PHP, which, as I said earlier, is actually most of the language. It keeps the clean request model, and it keeps the fast edit refresh cycle. Even with a static type system, even with a static type checker, we have a 100 millisecond response time in our type system to keep the same fast iteration cycle. Not only are you not waiting on a static type checker for even a few seconds to get your errors, you are getting your errors faster. The second you save your file in your editor, we can tell you something went wrong before you tab over to your browser and refresh and get a blank page. So what does Hack look like? Here's a simple sanitize and send function that iterates over some sort of input data, sanitizes each value, rewrites this in the sanitized data array, and then sends that to a database or something. What does this look like in Hack? Well, first of all, we have a couple of types here. We have this generic map, which replaces PHP arrays. We have maps and vectors and sets instead of this all-in-one data structure. Again, that means something if you know PHP. If you don't worry about it. We have this map, which is a map from strings to string. That's the data. We've explicitly said what its type is. We've also explicitly said what the return type is. It returns void, or there is no return. We then create a new map for the sanitized data, but we iterate over it with the same syntax, write into it with the same syntax, send to the database with the same syntax. This looks an awful lot like PHP. It behaves like PHP engineers would expect it to behave. What happens if you do something wrong? We have this map, but we're appending to it as if it were a vector. We're not specifying a key. You can sort of do that with PHP arrays. They'll just pick an integer key for you. Not really what you meant. You can't do them on maps in Hack, and this is the error you'll get. We will tell you within 100 milliseconds of saving this code, you have done an invalid operation on a map on line 6 here. You want to check out the definition of the map there. We can tell you immediately that something went wrong. It's worth noting here, on this example of my last one, where there are, but more importantly, where there are not type annotations. Importantly, we infer the type of sanitized data. You tell us it's a new map, but we infer what the generic type of that map is. I can still say $x equals 0, and we'll infer that x is an integer. You only have to write types on function input and outputs, the function parameters and return types, and on class members. All of the locals we can infer for you. You give us a little bit of information and we can figure out the rest. We can keep you moving quickly in PHP code just like you were before, except you're writing Hack now. Everything else is inferred. I'm going to just put this slide up for people that are language geeks talking about the Hack type system. We have all PHP types. PHP actually does have a very slight type system. You can specify class names, object types for parameters. Hack adds scalar types for parameters and return types. PHP internals is currently, I'll generously say, debating whether to add scalar types to PHP for anybody that's been following that debacle. I thought voting didn't close till tomorrow night. It passed. Great. So they have finally accepted scalar types into PHP 7, I guess. I hadn't heard that. Slightly different semantics than Hack has. Theirs makes sense for them. Ours makes sense for us. I'm happy with what they did. I'm happy with what we did too. We have a bunch of other types, tuples, closures, generics, constraints on generics that I'm just going to blow through here. Hacklang.org is where to go if you want the full details here. So it turns out PHP is a fairly dynamic language, and Hack goes to some effort to let you continue using the idioms that you had in PHP. So here's an example of something. In most statically typed languages, you have to pre-declare variables before you can use them. You don't in PHP because it's dynamic, and you shouldn't have to in Hack. We can, as a matter of fact, infer, even if this is the first time that X is referred to, that since X is defined in both branches of the if, it's defined after this if. And there's a bunch of idioms like this that we go to some effort in order to infer properly, in order to let you continue using the idioms that you're familiar with from your PHP. I actually gave an entire another talk on how this works, which should be going up on YouTube shortly on hacklang.org. The gory details of the hack type system and the implementation. I'm just going to blow through it a little bit now and talk about one other interesting feature. Should this work? I define v to be a vector literal of 3 integers, and then I want to append a string to that vector. Should this work? The answer is yes, this should work. I should be able to use this as a vector of mixed. Mixed means, well, it's a supertype of anything, and so this vector can contain anything. And so our type inference needs to, allow stuff like this, mixing integers and strings inside the same vector, but it also needs to keep track of it so that we can print an error here if you're trying to use this vector as a vector of int instead of a vector of mixed. Again, just a bunch of interesting things inside the type inference engine that let us infer idiomatic code, continue using Hack like you were using PHP in most cases, but have the full safety of a type system. So yeah, our error messages, we keep around this witness information so we can give you a good error message. On my last slide, I was returning a vector that had a string in it as a vector of int. We should go to say invalid return type, and furthermore say you said integer here, but you put a string in it here. We go to a lot of effort to keep explanations for what has gone on. Programmers shouldn't have to understand the gory details of our type inference engine. Our errors should explain them to them. Again, keep them moving fast. Keep the good parts of the PHP language, that fast iteration cycle, while adding a little bit of the safety of a real type, of a real type system. So again, that's the Hack language. You can get the full details of Hack at hackling.org. All of it's open source along with the rest of the HHVM project. Okay, so that's all I have for the talk. I believe we have a bunch of time for questions, which I'm happy to take. Oh, you okay?
The initial talk about the PHP to C++ conversion program mentioned the speed up of 2 to 5 times.
Yes.
What is the speed up of the new?
It depends on how you benchmark it. It depends on your workload. People have reported anywhere from like 5 to 50 times. It very, very much depends on how you benchmark it, what your workload looks like. It's really hard for Facebook to measure it nowadays. Back in the HPHP days, we hadn't changed the semantics of the language very much, and we could actually run them side by side and like measure ourselves what it was on Facebook, and that's how we got the 2 to 5 times number. In the intervening time between HPHP and HHVM, we've pretty dramatically changed the language. 98% of Facebook's code is now actually Hack now instead of PHP, and there's no other runtime for Hack other than HHVM. And so the benchmarks we get, so we can hand wave a little bit what we think it is for Facebook, which I don't remember the number. You can look also at things like WordPress and Drupal and other workloads outside of Facebook. The good numbers, though, are to look at like real apps like Wikipedia. That's about as real a benchmark as you get. And they dropped their latency for saving the Barack Obama page from 20 seconds to 6.9. So I'm terrible at arithmetic, whatever that works out to.
1/3 is the
Something like that, yeah. People have reported, if you do the right micro benchmarks, you can get like a 50 times speed up. That's probably not realistic. You probably won't see that. Somewhere in that range is more realistic, depending dramatically on your workload, your configuration, and like the phase of the moon and a bunch of other things.
What about things like runtime RAM usage?
People tend to report that RAM usage is better. Again, it depends on your exact workload.
Okay, thank you.
But RAM usage is more consistently reported to be better under HHVM than under PHP 5.
So you mentioned the HHBC runtime isn't really used that much anymore, that virtual machine. Does that mean that you're always compiling to native now at this point?
For Facebook, yes. the default configuration will always compile straight through HHBC to HHIR into native. The only times you'd run the HHBC directly are debugging if you're working on HHVM itself, or if you want to disable the JIT for some reason. There are a handful of bizarre edge case reasons you might want to do that. None of them come to mind right now. There used to be more reasons to do that. The JIT is really good now. The major one is if you're on Mac OS X. We haven't finished porting the JIT to Mac OS X. There's just like a bunch of like weird platform specific things we have to deal with on OS X before we get there.
Great
Are we going
talk.
back over here?
Yeah.
Sorry, I'll keep forgetting to bounce.
Yeah. Great talk.
Thanks.
If someone wanted to, if someone had a use case where they had an internal media wiki, let's say a typical use case, and they wanted to convert from, straight up PHP to HHVM setup, is there any kind of estimate guideline you could give on how much time and effort that would take? Is it? I mean, if you wanted to, is it real quick and easy to swap that over or not?
It depends on how customized things are. So we're a complete new reimplementation of the language, and there is now a spec for the core language. A lot of the API doesn't have a spec still. And so it's like up to us to find the corner cases and library functions that are not documented. One of my favorites is we found one recently that like one function converts integers and strings slightly differently than every other API function. If there's good unit test coverage of the framework you're using, if it's something like MediaWiki, Drupal, WordPress, HHVM.com/frameworks, we actually publish results of running unit tests on open source frameworks against HHVM. We track those really closely to make sure we don't have regressions. And so stuff like that is pretty well covered, and so you should be able to take Drupal, drop it on HHVM, and it will work. Because, like, we test that. If you have very customized Drupal modules, stuff from that somebody else might have written a few years ago that might take advantage of some other edge cases in the language, most of those will probably work. If they don't, it's a bug, but you may hit one or two of these bugs. They can be painful to track down. It gets better and better day by day as we track more of these things down, but the more off the beaten path of well-tested stuff you're going to hit, the more likely you are to hit one of these bugs. Most people do it without much incident, but again, it depends on if you just happen to hit one of these cases where we haven't replicated some behavior quite right. But again, please report bugs. If you do this, please file bugs. We want to fix these things. They are bugs.
It's really good to hear that you have Wikipedia changing now to HHVM.
We're really excited.
That's pretty cool, because I haven't seen any other big website besides Facebook using it. I've been trying to push in our company, which takes about 10 million page loads a day, to change, but the thing is that we've been experiencing a lot of issues, more than with PHP FPM. For some reason, on our test, on our load test, it keeps dying.
You mean HHVM keeps dying?
Yeah, the server itself, I mean, it runs again, but I don't know, one of 1,000 requests just dies, and the server restarts.
That's really interesting. First of all, that is a bug. Please file that bug if you haven't already. We would love to work with you and help track that down. I don't know if we'll have time tonight for me to actually talk to you one-on-one and actually debug this. But we hang out on Freenode IRC, #HHVM. If you or anybody else wants to come in there during the working day Pacific time, we're all based in California. Just come in there and talk to us. File an issue on GitHub. We love to look into stuff like this and help debug it as much as we can. If you can give us crash logs, anything like that. There are a handful of known issues that don't sound quite like what you're describing, but again, it should work. If it's not, it's a bug. Please help us help you track it down, because we want to fix it.
And is there maybe a book that you're trying to write down or anything? Because hack language keeps getting better and better, but if we don't have a real 1,000 pages book, it's not going to be that easy for the rest of the developers to change into hack. I mean,
yes,
using HHVM with PHP, sorry, it's good enough, but hack itself.
There is not currently a hack book. There's docs.hhvm.com is the best we have right now.
Okay, thank you.
Bob Gazelter. In HHIR, and this may be easier with the slide, but we'll try it without the slide. How do you transfer control between segments? To a vector table?
I'm actually not sure what that looks like.
Because so you have two branches. You had 4 segments.
Yes.
And if a conditional fork down one of two.
Sorry, let me actually bring up this slide so we.
Yeah.
Do you mean this?
Yes, that'll do.
Yes.
It's HHBC, but the previous
Yeah.
slide had the same configuration basically. You're going to go from 90 jumps to 30. I'm sorry. Yeah, 90 jumps to 30.
So the actual numbers in here, this is like clipped out of a larger setting in order to give a good example.
Basically, you're going to transfer to the block at the top. You're going to transfer to the block that's either beginning at 95 or 120.
Correct.
And then you're going to coalesce back at 140.
Correct.
Now, since when the JIT gets called, you're going to end up with a variable length section of code stuffed in the pool somewhere.
Into the translation cache, you mean?
Into the translation cache.
Into this yellow block, yes.
Yeah, you're going to have 4 clumps. The clump at the beginning, the clump that goes the hit case, the clump that goes the miss case, the clump that recoalesces.
Yep.
And they may be JITted at different times.
Not quite, because you're executing this function, right? So some of the specializations, here's like the final completion. So like one trace through, you're like not going to half execute a function. So you're going to go at least like here, and then to the return. Then you might come back later and regenerate more things with different types. But
Yes.
at least part of it will be contiguous.
But if the type changes, you'll be jumping to somewhere else.
Correct.
So the transfers have to be disintermediated, have to be intermediated by some mechanism.
Not
because
quite.
the end of the segment may not go to the place it went last time.
Yes, we actually go back and retroactively rewrite jump instructions so that happens. We will emit a jump into this blue block at the bottom if we haven't generated that code. Once we go back and generate it, we'll go to the end of that tracelet, remove that jump into the blue block, and actually rewrite the destination address.
So what happens? So if you have this brings the obvious follow-up. If you have a new type, a type change, you'll have to rejit the code.
Yes.
And if you change the type back, which I grant you this is a horrible case, but if you have a piece of code which is for some reason jumping back and forth between a string input and an integer input, which is sort of like a C class.
Yeah.
C classes would do this nicely, but overloading would do it nicely in C, but C++. But how do you handle that?
So we'll just have various specializations that'll all get generated.
Okay.
So for example, if you, I wish I had a laser pointer. I can't quite point at this. If you look at these 2 blocks here, we generated the int specialization for local 1 first, then the string specialization. When we generated the string specialization, this block right here, we rewrote that pointer to point into the string specialization. If we then execute this code again, and local 1 is a Boolean, for example, we'll fail the int test, go into the string version, we'll fail the string version, then this string right here is going to land back in the runtime, and we'll just keep chaining these together as the types keep changing.
Instead of patching the code, wouldn't it be better to use a transfer vector?
Sometimes, sometimes not. I don't work directly on the JIT, so I can't give you a good answer to that. I guarantee someone has looked at it. That might be the sort of thing that this is just sort of the easiest thing to do and works well enough, and the transfer vector is something that is future work on the JIT. I'm sorry I can't give you the good answer to the performance trade-offs there. You also shouldn't take quite what I said as gospel. I am 95% sure what I just said is the way that it works, but don't completely quote me on that. It is possible for me to be wrong. Like I said, I don't work too much directly on the JIT.
Hi.
Hey, how's it going?
Awesome talk. My name is Diego. I'm from Ecuador, South America. So it's my first experience here. It's awesome that
Great,
you
welcome.
have a user group here in New York. My question is, which IDE has a support for the Hack language?
So right now, not too much. There is Vim and Emacs. I don't know if you consider those IDEs or not. I consider them half IDEs. I'm a Vim user, and there's great support for Hack and Vim. Someone wrote a plugin for Sublime Text. Someone, I think, wrote a plugin for Atom. There is a Hack plugins wiki page on our GitHub wiki that lists them. JetBrains has told us they are working on support for the next version of PHP Storm. They've actually been to the Facebook office. I've talked to them personally and helped them out a little bit, and they are working on that. I don't think it's in their early preview yet, but they do intend to release it in the next version. Facebook is putting out our own IDE that we've talked about before that has hack support. For people that have heard about that, I promise it is coming eventually. We said a year ago it's coming in a couple of months. I really promise that it is coming soon this time.
Thank you.
And if you want to write support, the type checker that does the static analysis has a really nice JSON interface. You can look at the existing examples of plugins to see how they work. It's not terribly difficult.
Okay. Thank you.
Well, another one over here.
Yes, great. Thanks for doing this work on PHP. It needed it.
Very welcome.
Obviously, PHP continues to evolve. Hack is probably going to continue to evolve. How do you plan to track the two and to make sure that is Hack going to be compatible with PHP as it evolves?
So
as they both evolve.
I want to pick apart your question a little bit. Right. The way to look at it is that HHVM is a runtime for both the PHP language and the Hack language. As the PHP language continues to evolve, we intend to continue having HHVM have full support for PHP 5, for PHP 7, once what's actually in PHP 7 gets pinned down, which I think like today or very recently was like the deadline for RFCs to go to vote for 7. So as 7 becomes a thing, we will add support for PHP 7 to HHVM because we run PHP however PHP internals wants to define PHP. We also run Hack. So given that they have the same runtime representation, Hack tends to get new PHP features by default. So when PHP 6 got variadics and splats, it doesn't matter what they are, they were new features in PHP 5.6. Hack just got them for free because we added the support to HHVM. The runtime representation is basically the same, boop, we just get them. If internals goes in a direction that's something that is dramatically incompatible with what Hack is doing, that becomes a more interesting question. So the one that I've been thinking about a lot is what they're doing with scalar type annotations. They have picked up semantics in PHP 7 that make a lot of sense for PHP. I think it's actually a really brilliant compromise that ended up, I hear, passed very recently. It's not what I think is the right thing for Hack and what Facebook thinks is the right thing for the Hack language. So it's very likely that scalar type annotations will mean something different in PHP files and Hack files, but they're still fundamentally basically the same thing. And we can provide, we actually have some tooling to help transition from PHP to Hack. We love automated tools to do conversions like this, and so we can build out things to help you deal with these incompatibilities as they come up. I can't think of an example of something that PHP might add that would be so dramatically incompatible with Hack that it would be a problem, but we'll deal with that when it comes up.
And one more question. Can we just rename it PHP++ instead of Hack? Just make it more like...
So Hack's not really a great name.
Obvious, yeah.
Hack's not really a great name.
Yeah,
we also don't really want to call it PHP++. We want to keep ourselves a little separate from the PHP language for it comes like a lot of, I don't want to say legal trademark issues because that's like a bullshit legal answer, but there's also like the legitimate thing behind the trademark. We don't want to confuse people, right? We aren't quite PHP. We are our own thing, and we're continuing in that direction.
Last question over there.
Oh.
Is there any way to warm the HHIR cache if you're running PHP code as opposed to Hack?
You can warm it in either case, actually. There's like configuration stuff that we have. It doesn't. I'm trying to think of how this works. Yes, so Facebook does this. We have a script that warms it up. I wish I could tell you how exactly it worked and how much of it is open source versus not, because some of it's specific to like what endpoints we want to hit at Facebook. You actually might want to look at how, so since all of the infrastructure for MediaWiki is open source, you might want to see if you can figure out how they do it. It's going to be the best thing without me having to figure out a bunch of digging through Facebook stuff that I'm not going to be able to do tonight for you in order to give you an answer. But yes, warm-up is a good idea. We do it at Facebook. Since we're talking about like the layout of code, code locality is a big deal, and not chaining too much of these types together is a big deal. Like getting the hot code all JITted in the same page is a big deal. Like the actual order that things JIT is super important for performance. So warming it up on hot requests is a good idea, and I wish I could tell you how much tooling we have to make it work, but I don't remember. The one thing I know we do is that we don't actually... Oh, here's one case where the interpreter is used, whoever asked me that earlier. The first 11 requests after you start up HHVM are interpreted. We don't JIT them, we collect type information in order to use that and then we'll start JITting from then on the 12th request on. Which is a lot of cases we'll see bug reports where it's like HHVM works great up until the 12th request and then the world ends. If you see that, that's what happened. That's a fun magic number.